So tonight I'm presenting on intelligent tutors, their potential for education, and in particular their promise for supporting personalized learning, all situated within a backdrop of education reform and institutions struggling with digital resiliency as the global technology landscape progresses and the Earth's population and the demand for education grows. No conversation about intelligent tutors can take place without talking about artificial intelligence. And responding to some popular questions and misconceptions regarding AI versus the separate field of artificial consciousness or artificial biological intelligence. Now, these are not new questions. They've been present in our human imagination at least since the Industrial Revolution, and even longer they've been situated within broader political questions regarding fear of unchecked power. Now, I've talked about this extensively in previous presentations, so I won't spend a lot of time on it here, but here's a couple of quotes. One is from Daniel Dennett, who is an American philosopher and cognitive scientist at Tufts University, and the other is from Satya Nita, who works with IBM Watson. Both describe AI as being very limited. AI and artificial consciousness are in fact separate fields, and the field of artificial consciousness has progressed extremely slowly. So an intelligent tutor or intelligent tutoring system, or ITS for short, is an application of AI in the form of a computer-based tool that supports learning through one-on-one interaction between the learner and the ITS. In education theory, we talk about learner-centered principles, which include the following: tailoring learning to learner differences, supporting motivation, supporting self-direction, and pedagogical processes that are paced with each student's individual capacity relative to that student's existing knowledge and skills. Now, we know that contemporary learning theory says that we construct knowledge through interaction with others, and that one-on-one interaction is ideal. But this can be challenging given the industrial model of education delivery and typical student-teacher ratios. And we also know and are learning about through our teaching experiences that there are unique challenges relating to interaction in distance education settings in particular. So the idea is that the intelligent tutors can stand in to provide some of that one-on-one interaction, typically on behalf of the teacher. But I think with new advances in intelligent virtual reality, it may be that these intelligent systems are able to simulate peer interaction as well. So we're talking about simming teacher presence and social presence, which raises some interesting challenges to the community of inquiry framework. And I think as well some other interesting questions regarding motivation and cognition, which I'll talk about a bit later. Intelligent tutors place a high degree of control in the learner's hands. And while not all intelligent tutors are adaptive, those that are, they typically offer features such as the following: adaptive sequencing, adaptive problem generation and problem-solving support, student diagnosis, adaptive feedback generation, fading of scaffolding, and adaptive dialogue management, all of which promote learner-centeredness. This illustration here depicts an early example of an intelligent tutor that embeds the basic concepts of how intelligent tutors today function, primarily focused on that one-on-one interaction with a feedback loop. But of course today intelligent tutors embed much more complex technological systems and data stores, and have advanced from being a one-size-fits-all to become a tailored and personalized system with more active engagement. So conventional system structure of an intelligent tutor embeds three models. The domain model, which is the content knowledge that the intelligent tutor draws on for generating problems to pose to the student and uses as a reference criterion for assessing student responses. The student model, which is the qualitative profile generated of a student's cognitive and affective knowledge, their behavior, and their emotional state, which the intelligent tutor draws on or cross-references, for example, in selecting communications approaches. And finally, the tutoring model or pedagogical model, which governs how the intelligent tutor selects pedagogical strategies for the student, such as problem-based activities to present to the student, and what feedback to provide. And you can see here, you can get a sense of how these three models intersect and are mutually informing. And the student model in particular, I think, will spark a lot of questions as technology advances. And I'll talk a little bit more about that later. And if we look at these represented in an ITS learner interaction model, we get something like this. And you can see that the concept is actually not very complicated. Specific examples do get more complicated, such as IBM Watson, and when we look at how Watson learns. But the basic concept is still there. The intelligent tutor draws on the domain level, the domain model to generate a problem and presents the problem to the student. The student inputs a solution to the problem, and the intelligent tutor compares the student's solution to the knowledge contained within the domain model. The intelligent tutor then provides feedback to the student based on this comparison. The feedback informs the intelligent tutor's pedagogical response, such as what problem to present to the student next. And then the feedback also informs modification in the student's knowledge, skills, and action. So it parallels aspects of real-world learner-teacher interaction. Now, most of the ITS models I've looked at omitted this bit here, the teacher design team, which I have added. And I think it's critical to point out that there's a number of intervals at which, even from the beginning with the ITS AI being trained, there are many points of human intervention. So teacher presence is retained, though indirectly. So I thought that the previous model maps quite nicely to Laurelard's conversational framework, which I've done in this slide. Similar learning processes are supported. One of the things I'm really interested in exploring in my dissertation research is the idea of how conceptions of distance might change when learner-teacher interaction is mediated by artificial intelligence. How immediacy and transactional distance might be improved in distance education settings in particular. There's a lot of research literature that demonstrates that learning is improved through the use of intelligent tutors in the absence of direct learner-teacher interaction. So what is it about interaction that supports learning if teacher and social presence can be simulated? What stands out to me looking at this slide is that there is a similar feedback loop as in the conversational framework here, which is supported indirectly by teacher intervention. So, do intelligent tutors support learning? There's a lot of literature that says yes. Here's some examples comparing ITS with conventional classroom or training settings, and I've just quoted these here from someone else. Sherlock is an ITS designed to teach field maintenance procedures to Air Force ground crew mechanics on F-16 fighters. Another example is the Carnegie Learning Corporation's Algebra Tutor, which has been shown to support improvements in student performance, primarily in complex problem solving, but also moderately in basic math skills. And additionally, there's been a difference in how ITS has been implemented in North America versus China, and for what purposes. And I'll talk a bit more about this later. So let's look at a few examples of intelligent tutors and consider how they support learning. Here's an example of an IBM Watson-based intelligent tutor, and here we see a manipulatable digital learning object providing a lab simulation with multimodal engagement. And this example is particularly interesting because it's an example of how an intelligent tutor might be used in collaborative learning, students working together, which I think is an important direction that intelligent tutors will take as the technology advances. And I should also mention here that IBM Watson's group is currently partnering with the publisher Pearson Education. I work at the University of Alberta, where there is an important AI and machine learning center focusing primarily on health innovations. One of their products is an intelligent app called Shufti, which started out as an intelligent tutor for radiology education, but it's now being used by radiologists in clinical settings as a practice aid. This here is a screenshot of the training tool. It embeds competitive features, game design, and custom feedback, which fosters motivation and provides opportunities for practice and mastery, responsive to each student's learning pace and trajectory. As the slide says, the student moves their mouse over sectors of the image to locate lesions, and the thermometer gives them feedback as to their success. So it's also manipulatable as a learning object and simulates for students the experience of actual tasks that radiologists do in everyday practice. And here's a screenshot of Shufti 2, which is used for training as well as in clinical settings. The second iteration of Shufti is more sophisticated, drawing on aggregate case data to provide radiologists with prediction confidence levels as they examine regions of interest in radiologic images. And you may have heard of Professor Ashok Goel at the Georgia Institute of Technology, who implemented what he named Jill Watson, a Watson-based intelligent agent, and he implemented Jill as a teaching assistant in one of his courses alongside human teaching assistants, primarily responding to students' questions and providing feedback in the discussion forums. Not strictly an example of an intelligent tutor, but it's an interesting case because it provides a glimpse of where AI is heading in education. And no, Jill Watson did not pass the Turing test. And does everyone know what the Turing test is? The Turing test is if a human can tell the difference between a machine and a human in dialogue and real-world scenarios. But as we can see here, students in the course did begin to suspect that Jill was an AI, and Professor Goel explains that this was because Jill responded so quickly to students. It's also an interesting case because of the ethical questions stemming from the use of deception in research. So here's a typical example of student-Jill interaction, and you can see Jill provided quite organic responses and interaction. However, the bottom image here demonstrates Jill's shortcomings in terms of emotional responses, which is currently one of the directions that development is taking in AI. And we've read about how important emotional affect can be in distance education settings. And in our teaching internships, this is what we've been seeing, or at least this is what I've been seeing, the difference that it makes to student motivation and engagement to demonstrate emotion in moderating discussion forums. But again, we're not talking here about the AI itself being imbued with emotion. Rather, the AI would simulate emotion. So here's a vision of how an intelligent tutor might be used as a classroom aid. We see the AI tutor collecting metrics and feeding these back to the teacher, who can then provide intervention as needed. And it's not difficult to imagine how this and the other examples we've looked at might function in a virtual classroom or in a distance learning context in general, especially if intelligent tutors become increasingly web-based. So I'm coming to the end of my time for this presentation, so I wanted to quickly point out some important questions and trends relating to intelligent tutors before my time's up. One of the things to note is that many intelligent tutors are not open in the sense that they're modifiable. They may use open apps for development. Shufti, for instance, was developed using Ruby on Rails. But they do require specialized skills to develop. So I think one future trend might be for much of this orchestration to become embedded into the tool, such as we see now with WordPress and Squarespace content managers, for instance. Additionally, integration with learning management systems can be complex, also requiring specialized technical skills, and a lot of this has to do with different data models and algorithms used in machine learning data processing. But I think the technology is and should be heading in this direction towards an intelligent LMS to support both learning and teaching. One of the things that is most exciting to me is the potential for intelligent virtual reality. In addition to providing opportunities for adaptive simulation and experiential learning and creating virtual worlds where distance may be mediated, I'm most excited about intelligent VR expanding opportunities for reflection for learners. One of my previous papers talked about how our process of constructing knowledge changes when symbolic representations of objects move from abstract representation by words or 2D images on a page to high-fidelity 4D manipulatable replicas. Multimodal reflection is expanded, with learners even becoming creators of VR content. Not only does this open up new pathways for self-assessment tied to reflection, but it also allows the teacher to assess much richer evidence, external observations evidencing a learner's cognitive change, including their procedural knowledge and metacognition. And this is exciting because it suggests that new learning taxonomies are needed to capture this, moving away from Bloom's taxonomy to more rhizomal models. So recall that my previous slide talked about the student model. I described that the student model contains information on a learner's knowledge, emotions, and behavior. And in fact, AI has the capacity to build and store very complex psychological profiles of users, which in educational contexts raise some very important questions. Supporting learner-centeredness is a positive aspect of this, but there are, of course, privacy concerns regarding the collection, storage, stewardship, access, and use of personal data. But I think we also need to consider new dimensions of hierarchy and power imbalances within teacher-learner relationships that could arise, stemming from teachers having access to this detailed personal information about their students. How will this change teaching presence and students' learning experience? These are very important questions. And society will need to proceed very carefully and purposefully in relation to these questions. For instance, one article that I read recently was describing how an intelligent tutor is being used in face-to-face classrooms in China as a behavior management assistant. The ITS scans the classroom every 30 seconds and records and provides metrics which may inform teacher intervention. In the article, the student describes how this surveillance has impacted his behavior. And again, this might be a good thing, but it does raise questions regarding motivation stemming from new avenues of accountability. So this is one example where extrinsic motivation is privileged, stemming from a new relationship with intelligent technology. So the title of my presentation is Intelligent Tutors in Education 3.0/4.0. And you'll see here that currently we're positioned in this interval between Web 3.0 and Web 4.0. We're beginning to see widespread use of rudimentary AI, as well as some more sophisticated AI in our everyday interactions that are mediated by the internet. And this will expand as we advance through the Internet of Things era. Intelligent tutors have been around for a while, but they've not yet lived up to their full potential, nor has their usage become mainstream. For example, in North America, their use has been largely confined to delivering content and assessments, though we've started to see some advancement in intelligent tutors behaving intelligently and interacting organically with human users. The 2018 New Media Consortium Horizon Report for Higher Education estimates a 2 to 3 year time to adoption for adaptive learning technologies and artificial intelligence, noting that AI in particular, and its role in conjunction with adaptive learning technologies, is critical for implementing personalized learning and is changing learner-teacher interaction in ways that enable more targeted and accurate scaffolding support. In addition to this, training is ramping up to produce skilled AI programmers, as well as to support educators in gaining AI competencies. So we see the kernels of education reform starting at a time when institutions are struggling with digital resiliency and governments are negotiating new knowledge-based economies. And we can really see this if we look at China as an example. In 2017, China proposed a next-generation artificial intelligence development plan, which taps EdTech as a critical target. AI development has flourished in China compared to moderate engagement in North America. I'm taking this from this article here, and it's referring mainly to business startups. LAIX, pronounced likes, is one example from China, and It had its first IPO offering on the New York Stock Exchange recently. It's an AI-based language learning program supporting 7 different languages. And learning is entirely independent, meaning that there's no teacher involved whatsoever. And this is another question regarding intelligent adaptive learning. Can AI actually teach? Quoting from this article, U.S. startups generally back away from using AI to take care of the teaching itself, employing it instead as an aid to take care of more routine tasks. At many Chinese startups, meanwhile, it takes center stage. So we have questions regarding social constructivism and learning when some or all interaction is mediated by or taken over by machines. Can AI adequately simulate teacher and social presence? Or for instance, how does the concept of teacher presence change when the teacher is one more step removed from the student with an AI intermediary? Can an AI mediator increase immediacy in learner-teacher interaction, even in the absence of direct learner-teacher interaction? Can this new type of distance actually serve to mediate distance? And finally, because it would not be one of my presentations without at least one Star Trek reference, I leave you with this image of a young Spock at his Vulcan school, where students learn independently in pods with an intelligent tutor type tool.